This video is on inverse functions. So a function only has an inverse if it is a one-to-one function. What that means is that for each value of y, there is only one value of x. Things like quadratics, parabolas, they do not have an inverse. And the reason for that is because when we do the inverse, it then doesn't become a function anymore because it would fail the vertical line test. The inverse of a function is denoted by f negative 1x. As you can see here, it's got a little negative 1 in the power. The inverse of a function reverses the effect of the function. So if our original function at 2 equaled 4, then the inverse at 4 equals 2. So the x and y switch. The domain of the inverse is the same as the range of the original function, and the range of the inverse is equal to the domain of the original function. Now, just one quick example. We have a graph here of a function. First of all, I want to explain why it's invertible, and the reason is because it's a one-to-one function. Each x value only has one y solution, and each y solution only has one x associated with it. If we want to sketch the graph of an inverse, the first thing we need to do here is we'd like to draw the line of y equals x. So the coordinates of that will be 1, 1, 2, 2, 3, 3, and so on. So it's just going to be a diagonal line straight through the graph, like that, and then we reflect the original graph across this line. Easiest way to do that as well is look for some points. So we've got the point here at negative 5, 2. So remember, with the inverse, we switch the value. So on the inverse, it will be at 2 and negative 5. Then another point is the ending point here, which is at 3, 4. So on the inverse, it would be at 4, 3. The y-intercept here is just below 4, so we can have a rough guesstimate on our graph of where it will be. And then from there, we can then draw the graph. When we draw the graph of the inverse, we just want to make it match as much as possible to what the original function is, and it's a reflection across that middle line of y equals x. Now, let's take the domain and range of both the original function and the inverse. So remember, for our domain of our original function, which is all the possible x values, our x is on the original go from negative 5 to 3. Nice and easy. And the range is our possible y values, which go from 2 to 4. And then for the inverse, they are just switched around. And if you look at the graph of our inverse, we can see that's the case. Piecewise linear models. A function whose graph is made up of line segments is called a piecewise linear function. One example again, for the piecewise function, f of x equals 4 between negative 2 and 3, and negative x plus 7 between 3 and 7. A piecewise function puts together two separate line segments and joins them together in a graph, and with a piecewise function, you always have this section at the end, which tells us the domain of each part of the piecewise. Part A in this question, we want to find f at 0, so when x is 0. First thing we want to look at is which equation, when x is 0, does it come under? And it comes under this first one, because the domain of the first function is between negative 2 and 3, and 0 is between that. Now, a function of just 4 means for any x value, the answer is 4. So that's really easy. F of 0 equals 4. Now, f of 6, look at which one that comes under, which will be the second function, which means then we need to substitute 6 into x for the second part of the function. F of 6 would equal negative 6 plus 7. That's our original function is negative x plus 7. So the 6 in for x, and that would equal 1. State the domain. Domain is just all possible x values, so just go to the function here and we can see it's going to go from negative 2 to 7. That's our smallest x value is negative 2 and the largest x value is 7. You can just get that straight from the piecewise function we've been given. Plot the graph. So when we're plotting this graph, we can see our x's need to go between negative and 7, so that gives us some guide there. A graph of just f of x equals 4 is a horizontal line because every solution is 4, and from the question that goes between negative 2 and 3. So between -2 and 3, we just draw a straight line at y equals 4. -2 is included, which means we have a closed-in circle at the start. Now to work out the second line with -x plus 7, because it's a straight line, what we need to do is we need to work out for 3 and 7 what the values are. So we know where to start and end. So we want to know an f at 3, which will be -3 plus 7, which equals 4. And then f of 7 would equal -7 plus 7, which equals 0. For the second line, it's going to go between 4 and 0 on the y and 3 and 7 on the x. So it would go something like this. Then as 7 is included, at 7 it's a closed-in dot. That's the piecewise graph. Another quick example, the cost of printing invitations depends on the number of invitations printed, as shown in this piecewise model. Find the gradient of A, B and BC. So for this we just use our normal gradient formula. So for AB, the gradient, we need our points of A and B. A is 0, 0 and B is 150. So our gradient would be 50 minus 0 over 100 minus 0, which equals a half. And then we want the gradient of BC. Coordinate of B, we found before, 150. And then the coordinate of point C is at 200 and then 80 for the y. Work out the gradient of BC. 80 minus 50 over 200 minus 100, which gives us an answer of 3 over 10 or 0.3. Now it wants us to interpret our answer. Now this is just looking at the gradients. One is a half, one is 3 over 10. So the gradient of AB is greater than the gradient of BC, which means the cost of invitations up to 100, which is point B, is greater between 0 and 100 than it is for between 100 and 200. Find the cost of printing 60 invitations. First of all, with something like this, go straight to the graph and can you read off the graph? We want 60 invitations, which will be here. Just go up to the line and read across. And you'll see that that is at $30. Patsy, how many invitations can be printed for $74? 74 isn't easy to read on the graph, so sometimes we may need to make an equation. With this one, remember our equation of a line, y minus y1 equals the gradient multiplied by x minus x1. $74 will be somewhere in this section here on our graph. I've just circled, which is in the second line, so we just need the equation for BC. And we can pick any point on the line of BC to plug in. I'm just going to go with the B point, which will be when y is 50 and x is 100. Now we want to when the invitation has $74. $74 is our y-axis. So we can plug in 74 for y. And then just plug that in your calculator and solve it. And you will find out that the number of invitations is 180. Now we're going to look at systems of equations. Just one example. In previous videos, you can look at simultaneous equations for 2 variables. This is just one where you have 3 variables. And in this example, we've got a table that has a quantity and volume of air affected by smoke t seconds after a fire is started. V and T are connected by a cubic model of this form. Find the coefficients of A, B and C. Now, just because there are 3 variables here and not 2, we can still solve them simultaneously. It just needs we should have 3 equations. Because we need to find 3 coefficients, we need 3 equations. And our question here gives us values to make 3 equations. So our first equation, we're going to be having when t equals 1, v equals 2. And we can just plug that into our equation here that I've just started. 2 equals a multiplied by 1 cubed plus b multiplied by 1 squared plus c multiplied by 1, and then you can just simplify that down to 2 equals a plus b plus c. Our second equation is going to be when t equals 2 and v equals 4, just reading straight from the table. Our equation then will be 4 equals a multiplied by 2 cubed plus b multiplied by 2 squared plus c multiplied by 2. And then we can simplify that down to 4 equals 8a plus 4b plus 2c. And our third equation uses the third set of data from the table, which is when t equals 3, v equals 12, and our equation would end up being 12 equals a multiplied by 3 cubed plus b multiplied by 3 squared plus c multiplied by 3, which simplifies down to 12 equals 27a plus 9b plus 3c. And then from there you can plug to your simultaneous equation solver on your calculator, and when you do that you'll get the solution of a equals 1, b equals -3 and c equals 4. And now I'll just quickly show you how you put that into the TI Nspire calculator. So on our calculators to solve systems of linear equations, what we need to do is, on a calculator page, go into menu, number 3, algebra, number 2, solve system of linear equations. In here it asks for how many equations we have. For this example we had 3, and then our variables were a, b and c. And then press OK, and it comes up with this where we can input our 3 equations, and we just input them as we had them before, which was, first one was 2 equals a plus b plus c. Our second equation was 4 equals, and we had 8a plus 4b plus 2c. Then our final equation was 12 equals 27a plus 9b plus 3c. Once you put them in, just press enter. Now check here that your variables in your equations match the variables at the end here, otherwise you'll get an error. Press enter, and it gives you our solution there, which we wrote down before, of 1, -3 and 4.